trigonometric function of a 90-degree angle. It's the same. To solve for sine 90 degrees, what was it? How do we get sine theta again? Huh? Y over R. R is equal to? From here, I have 0.01. Therefore, R is equal to? 1. So basically, we are talking here of a unit circle. And this 0.01 is the intersection of the unit circle and the terminal side of your angle 90 degrees. So if I have R is equal to 1, this is my terminal 0.01. Therefore, sine of 90 degrees is equal to? Y over R, right? But what is my Y? 1. R is equal to? 1. Therefore, sine of 90 is what? 1. Cosine 90. 0. X over R? Correct? And you have X to be? 0. And R is equal to 1 again. So, therefore, cosine of theta is? 0. Now solve for the tangent of 90 degrees. Y over X. So, Y is 1, X is equal to? 0. So 1 over 0 is?
Undefined.
Undefined. So you cannot have a division by 0. So any real number divided by 0 is undefined. So tangent of 90 is undefined. Okay, what about for cosecant? R over Y. Right? So you still have 1. Second of 90 is? You have R over X. So this is, again, 1 over 0. Undefined. And then lastly, for cotangent of theta. 0. So those are the trigonometric function of a quadrantal angle 90-degree angle. So say for example, if I have here a 180 degree, I can choose my terminal point to be negative 1, 0. For 270, I can choose 0, negative 1, and 0 is 1, 0. So you can verify it yourself that whenever you have this terminal points for your quadrantal angle, you can also get the same, not the same, but you will get a values of your trigonometric function, and we have here the tabulated form of those values. So let's have verification. For a 90-degree angle, again, we solve that the sine 90 is 1. Cosine of 90 is 0. Tangent of 90 is undefined, correct? And then cosecant, second, cotangent is 1, undefined, 0 respectively, correct? Okay, so you have there the trigonometric function of quadrantal angle. And this is also true when you have a coterminal angle. So, say for example, if this is my 90-degree angle, right? If I have the coterminal of 90, say for example, negative 270. Is this a coterminal of 90? Yes, because the terminal side of negative 270 and 90 are the same. So the values of your coterminal angle negative 270 is the same as the value of the trigonometric function of 90. So even for coterminal angles, you can also choose here terminal point 01, for example. So it doesn't really matter. Question.
None.
Verify this yourself, okay? Like for 0, 180, and 270, and then use the corresponding terminal point. Question so far? No? No? Understood? Okay. Let's go here to of my trigonometric function? So actually, the signs of your trigonometric function, it depends on which quadrant the terminal side of your angle lies on. So let's have here four quadrants of the ordinate system. This is first quadrant, second quadrant, third quadrant, and then the fourth quadrant, right? So, what are the signs of my coordinates here in the first quadrant? You have positive, positive. Second quadrant?
Positive. Negative, positive.
Negative, positive. And the third quadrant?
Negative, negative.
This is negative, negative. And then lastly?
Positive, negative.
Positive, negative. So, here on the first quadrant, x and y coordinate are positive values. Here, negative for my x values. So any angle whose terminal point, say for example, if I have here an angle that lies between 0 and 90. So basically, the terminal side of this angle is on the first quadrant, right? So if I have here point P of xy of this angle on the first quadrant, basically this x and y are both positive. That means any angles whose terminal side is on the first quadrant between 0 to pi over 2 or 90 degrees, x and y are greater than 0. That's if the terminal side of your angle naman is on the second quadrant, you have there that x is less than 0 and x is greater than 0. And same is true for the third and fourth quadrant. You can see here that if the terminal side naman of your angle is on the third or the fourth quadrant, you can get there that the values of your x and y will correspond to this signs here. Since as well you have by definition the definition of our trigonometric function is in terms of the ratios not x or y divided by r. But take note that r is your distance from the point of origin to the point P. So by that we mean that your distance is always positive. We can never have a negative distance, right? So technically you know already that r is greater than 0. So if I have from my definition that sine theta is equal to y over r, I can determine immediately what is the sign of my sine function. If r is always greater than 0, how is this positive? I can only have a positive sine function whenever y is greater than 0, right? So if this is greater than 0, that means this is positive and this is positive. Therefore, I have here a positive sine function. Also, for cosine naman, you have cosine theta. This is a ratio x over r. So the only thing that matters here is the sign of your numerator. So x here is less than 0, that means cosine is negative. And if this is positive, cosine function is positive. So you can see here that if x and y are both positive numbers, so basically sine, cosine, tangent function are all positive functions. If in case you have there in the second quadrant, therefore x is less than 0, y is greater than 0, therefore the only positive function of the second quadrant is sine function, correct? On the third quadrant, you see here that the only positive function is tangent. While in the quadrant 4, the only positive function is cosine. Okay? And you can remember it with this acronym. ASTC, what does it mean? A. All positive. So on the first quadrant, all trigonometric functions are positive. On the second quadrant, the only positive function, as I've said, is sine. And then the third quadrant, you have tangent, and this one for cosine. But we know already that this trigonometric functions has the corresponding reciprocal functions, right? So if this sine function is also positive, then the reciprocal of sine, which is cosecant, is also positive. That means here, aside from sine, I can also have the reciprocal of sine to be cosecant, and this one is also positive. Also for tangent, which is reciprocal of cotangent, that means this is also positive, and cosine and secant. So those are the positive functions depending on the location of your terminal side of your angle theta. Questions so far?
Yan.
Yes? No?
Yes. Punta naman tayo.
Okay.
Diretso lang.
Okay. So that's how you locate the terminal side of your angle, and then from that you can identify the signs of those functions. Let's have an example. Okay. Cosine and sine theta is what? Less than 0. Okay. How do we solve this one? Any idea? Okay, how do we solve this one? Okay. Let's have a recap first. Who can give me trigonometric identities we have discussed from our second topic? Yeah, sine plus cosine plus cosine. Sine theta plus cosine theta is equal to 1. Is this correct? Squared. You have sine squared, cosine squared is equal to 1. Any other trigonometric function? I mean identities? 1 plus tangent squared theta is what? Okay. What else? Cotangent squared. Okay. What else?
Dala na ako.
Can I have
Hindi ako
here
mapokas na.
tangent of theta? This is sine of theta over cosine theta, right? What else?
Well, sinulat mo yan, no? Sinulat mo. Sinulat mo. Sinulat mo. You write that. Rewrite it.
Write that.
Ayun. Sorry.
Okay. we have more.
You seem so offended because
I'm not sure. I just put lang somewhere.
somewhere out there.
Okay, we
Pantay
can
na.
recall the others later if we will need them. Okay, how do we solve this example then? I have a value of cosine theta which is 3/5. Cosine is 3/5. Sine theta is less than 0. So from there, which can we use? Any function there that involves cosine, sine something? Huh? The first one. Okay. This is one. Using the first identity, you have sine squared theta plus cosine squared theta is equal to 1. Next. How can we continue from this identity?
Transfer sine squared into the other side of the negative.
I transfer sine squared. This one?
No. That's yung other way. Sine equals
Sine here.
yeah.
I have cosine is equal to 1 minus sine squared.
Nagklase pa tayo. Nagklase pa tayo.
This one?
Nagklase mo.
Huh?
Sine is
I
negative.
will take note that we have to find the trigonometric functions of theta. I already have here cosine theta to be 3/5. So do I need to solve for cosine? No. So which one can I use? Sine squared. What's the value of sine then? Yes? 1 minus. And I have here squared, right? Because this is cosine squared. Cosine again is 3/5. Taking the square, the value of sine is what? Okay, from there you have sine theta should be the square root of this one, right? And the square root of 1 minus 3/5 squared is? One minus the square of 3/5. This is 9/25. So 1 minus 9/25 is what? And then the square root of 16/25 is? What's the square root of 16? Question.
Professor Angelina, I have a method.
Huh?
I have another method.
You have another method. Okay. What
Is
did you
it
do?
possible to
Yeah.
try?
I mean, you can try.
Yay!
Okay. While he's writing his method, we can continue this one, okay? And then we shall see if both answers are correct.
Go!
No, that's fine.
Hard.
And that's fine. I mean, I like
Hilak.
for my students to try, and then we can check it out if that's correct.
So how I did it is a very easy situation.
Yeah.
Since I know that
Okay, first write your solution here and then you explain.
Makita,
But
hindi
I'll
makita,
continue
hindi
this
makita.
method, and then we can check if both trigonometric functions are the same. You can do that, right? Okay, from there, I have sine theta is equal to 4/5, which is the square root of 16/25. But take note, what do we have here? Sine theta should be less than 0. What's the missing Same here. Negative. Okay, take note that whenever we get the square root of something, this is equal to positive negative 4/5, right? So if my sine theta is less than 0, then I can have my sine function to be what? Negative 4/5. So this is now my sine value. I have here cosine value. So we can solve for next trigonometric function, which is tangent. I can use which trigonometric function? I mean identity? Sine over cosine. I have your values of sine cosine, right? Sine is negative 4 over 5. Cosine is 3/5, correct? Therefore, my tangent theta is? What? Is equal to? Negative 4/3. Now that's my tangent theta. What about for cosecant theta? This is equal to?
Always
This
be
is equal
happy.
to? Yeah, you got the reciprocal from the sign. So you have here negative 5 for
Uy.
unity. Okay, next. Second
Lawrence.
of
Lawrence. Somebody.
theta. Second of theta is 5/3.
No to him.
And then cotangent would be negative 3/4. So these are your trigonometric functions. So we now have here the values of our trigonometric functions. Okay. Explain.
Explain. Elaborate.
You see, I'm not an expert, so I just tried to memorize the SOHCAHTOA.
Uh-huh.
So I thought of the adjacent hypotenuse.
Mm-hmm.
So I tried to imagine a triangle. So I tried to put the numbers, so adjacent 3 and 8, hypotenuse 5. Just by making a random guess, I would put 4 here, although I'm not sure that it would be negative. I was just guessing. So, so
Okay, sorry, continue.
it's alright, right? So on the sign, of course, just imagining this triangle, I just used the SOHCAHTOA. So this is hypotenuse. Supposed to be negative 4, which I did not realize that one. So I just put 4 over 5 and then SOHCAH, adjacent hypotenuse 3, 5, tan, opposite adjacent, negative 4, 3, and then just flip it up. And that's it. So yeah.
Okay. Thank you.
Yeah, thank you very much.
Okay, what do you think about the solution?
You try your best. You try your best.
Much faster? Yeah. But do we have here, like, how did you guess the
Do you get?
size here?
So that you cannot guess the signs, it's already given. Sign is less than 0. So if the cosine is all positive, meaning sign is negative, so one of the values will be negative, which is 4. And that is a Pythagorean table, 3, 4, 5, so negative 4. That is why it is negative.
This is much more easier than what I thought when I was answering as Alex. Because in the Alex, I was like, how is this possible? And then like, since sine is negative, I was like, what is this negative? And then the other, and then adjacent was negative. Because cos is positive. So it's
But take note here that we are not given with any right triangle. So we cannot just like point here, this is my side 5, this is my side 3 or something, even if cosine is defined to be adjacent of our hypotenuse, okay? I mean, we have here the same answer because, again, this is still ratios. So, for example, if I have your cosine theta, this is equal to
You
3/5. This
just
could
put
also
like
mean
that
that
in your part.
my value of x is what? If you simplify it, you have 3/5,
So
right?
it will not be damaged.
So you could have values of x as well.
There's some
I
laptops
mean,
out there.
the opposite adjacent of hypotenuse, but that would be like a ratio form version, like a simplified fraction, I guess. So, still, but I would recommend for you to do this identity.
You said we will know if it is the right line. You can only use of know if it's the right line.
Yeah. You can only use it if you have a right triangle. Question? Question. How much time do we have?
10 minutes.
Okay.
Assign.
10 minutes is enough for this one. Get one piece of paper and then answer. You have here cotangent theta is -150.